Hello and welcome to the fourth video of this coding that we're making a shooter type game for. Now, I'm going to do this time is I'm going to clean up some of the stuff, like specifically these kind of static numbers. I'm going to make them more random just so I'm using random range, but don't have to hard code this to 75. I can actually set this to the size of the image. And there's a reason that I'm going to do that, because we're going to change up the actual image a little bit. Instead of just using A, we're going to use all the letters of the alphabet. So we're going to do a couple of different things, but first let's just see what we have in store. So let's run the example. Now you'll notice we have pretty much the same thing so far. You notice all of our letters, they're actually different now, so they're not all A's. Of course, we still have movement, but this is the biggest thing we're going to be working on, and that is we're going to be firing these. So this is where the shooter game comes in. You'll notice that there is a little bit of weirdness if you watch the blue box when I shoot down here. You'll notice they kind of come out of the side. That's an offset that I'm dealing with because due to integer division and the fact that you can only move pixels at a time, you can't move half a pixel. Usually all of these letters strangely get offset whenever you shoot them. So just to make sure that they always end up where the mouse is, I'm just causing them to offset when they get shot. Because of course our boxes, if we spawn them in the center when we fire them, our box is 50 on every side. So we actually have that little bit of distance where we can work with. And I think it works much better because it favors accuracy over, I guess, perfect, actual graphics, because you notice how they spawn at the bottom instead of more toward the center up here. But I guess that's just preference. I prefer them to be more accurate. So enough with that. Let's actually get to this. The first thing I want to do is create a function to deal with this. So this is a really long line just to get a font. Let's start by making something that'll get the font for us. So I'm going to define a new function called getFont. Now it's going to return the font. So we know the fonts we want are pygame.font.sysfont, and then we have some type of name here, we have a size, and then we have a style like bold or italic. So this is what we're returning. Well, what's the name? I'm going to say name equals, and when you put equals inside of the function's definition, it sets these as basically starting points. So if I say courier new, and then I say size equals, let's say by default, it's going to be 20, and then style equals, I'm going to leave it blank, which means no style will be selected just by default. And now when I do my rendering, I don't have to say all of this. I can just call getFont. Now if I just call getFont, it's going to set the name equal to courier new and fill out name. It's going to set the size equal to 20 and fill out size, and it's going to set the style equal to an empty string, so it's going to leave style as blank, meaning no style. So actually, if I run this real quick, you will be able to see that, well, it's actually really hard to see them, but they're all really small A's that are not bolded. So let's change that up. We want to get a font and we want to change a few things. So what are we going to change? Well, we have to say size equals and then give it a new size. I liked 30. I think that was a pretty good size. We'll add a comma and say style equals bold because we want it bolded. So now when we run this, you'll notice we have bold 30 size letters. So they're all still A's at this point, but you see how this works. We create a function that returns a font with a name, size, and style, and then we just default all of the styles. We default the name to courier new. If we wanted to change that, we could. All we'd have to do is come in here and say name equals and then something like a new string name. So we could go with Arial, and that would change it. And of course, this will run. There we go. They look a bit different because it's a different font. I'm going to leave it as the default font, so I don't need this string here. Now, when you set defaults like this, if you're going to change all three of them, then you don't actually specifically have to say style, size equals, style equals. You can just enter a name, a size, and then a style like normal functions, where you just enter them in order. But when you actually set defaults, if you're only going to change one, then you have to specify what you're changing it to. So we don't want to just render A's. How are we going to take care of this? Well, we need to set up some type of string up here. So I'm just going to create a new category up here. I'm just going to call them globals. And then I'm going to say character list equals a string. Now, this is going to equal an actual list. It's going to be a list, but what is going to be inside of this? Well, let's hit caps lock. So there we go, just copied it in. Now I've separated each of these letters by a space, and I'm using the capital form of them just because it shows up more clearly than the lowercase letters. So I've done A space, B space, C space, D space, all the way through. And the reason I'm putting spaces is so I can do an operator on strings called dot split. Now split, you could separate these by commas. Whoops. If you separate them by commas and then add a string of what you want to split it by, then like this, for example, this will split it by commas. You can also say split by space. Split by space is the default, so I'm going to leave it as just split. And what this does is this actually returns a list. So what this is going to return is something that would look like this if we said character list equals a list, and then we did A, and then we did, B, and so forth. But this is just a faster way of actually typing it out, and it gives you the same thing. So there, now we have a character list. So if we want to not just use A, how might we do this? Well, we know there's a random function called random.choice, and then all we do is feed it a list, so we'll give it the character list. And there we go. Let's try this to make sure it's working. There we go. We have a G, we have a W, we have an F, we have an I. All right. We're getting a bunch of random letters. And of course, we could check if we wanted to, we can just add a space, maybe add a 1, add a 2, add a 3. It doesn't matter. We can add as many as we want as long as we put a space in between them or define our separator inside of the split. Doesn't really matter. I'm going to leave it as it is. So let's see. We could also change up the size, because when we do image.getFont, we give it a size. We could do a random int. So, randint from, say, we want this thing to be maybe between 20 and 30. And then when we go to run it, we'll notice we have varying sizes of these letters. So I'm actually not seeing any 30s. They all look like they're 20. Oh, 20 to 20, that's why. If I could type right, then maybe we might be able to see something neat happen. There we go. Now you can see that there are several that are different size fonts now. So if you like them having multiple sizes, go for it this style. I prefer them to all be the same size though. That's just my preference. So I'm going to default the size to just be 30. Actually, 30 was a bit big. Let's go with 26. I think that's what I used in testing and I like that number. There we go. We have our font size. Now we're going to change up where these things spawn. So they can spawn as low as 0. It really doesn't matter if they spawn at 0 or not. And the max. Well, what is the max that we can spawn them at? Well, let's see. Our bullets spawn a max of 100 minus self.rect.width. And of course over here will be 100 minus self.rect.height. And the reason this is because this is spawning it at 100, which is the max of our character's image. And then it's spawning it minus its width. So it only spawns on the right side and will never actually go outside of the box. So we just randomize this more. This is much more useful if you are using various sizes of these, because if you're going to use multiple sizes, randomly picked sizes, then changing up the width and height will just make them always be able to spawn as far over as they can, just to randomize how they move inside a little bit more. Now, we're going to do a few more functions. I don't think there's anything else I really wanted to clean up all that much. Everything seemed okay, as far as I'm aware. There was one more thing right here. So I'm just saying if for all of these. So what this function is doing is when we move it, it's saying if the object is, on the right side, change its x direction. And then we're saying if the target is on the left side, change its x direction. But the problem with this is only one of them should ever be able to happen at one time. So I'm just doing a couple unneeded checks, basically. So if I actually move this over here, there we go. And I just say elif, which is the Python's form of else if, meaning either this is true or this is true. If this is true, ignore this line, don't even bother checking it. If this is not true, then check this line and try it. Because this basically just halves the checks that this has to do for each of these. Now, it doesn't really matter when there's only 4 checks that we're doing each frame for this, but if you're doing like 100 calculations of something, else ifs and ifs are really useful, especially if only one can be true at one time, because then there's no point checking the other one. Like, if this is all the way on the right side, there's no way it's also all the way on the left side, unless it's a gigantic word. So there's no real purpose for us to check both of them. And then, of course, we can just clean this one up by also saying elif. This doesn't change how anything operates. It just makes it so that we don't have to check both of them at the same time. Okay, so I just checked through the code. There's nothing else I really want to clean up. So let's get started with just defining all the functions we want to try and get done. So define get target, which is one function we're going to be using, and I'm just going to pass them for now just because I want to get them all laid out so I know what I'm trying to do. And then inside of the player we have move, spawn ammo, move ammo. We also need another function called shoot. So let's see. Define shoot. We're going to pass it, and actually I need one more. Define update. Because we're going to be putting something inside of update. It's going to be really small, but it's going to help us with our shoot function. Okay, so let's start with shoot. Now, when we shoot, we're going to assume that the mouse has been clicked. We're not, and when the mouse is clicked, then this function is called, so we know we're supposed to. So all we have to do is say, let's actually create a couple variables first. So let's go back to our main player thing here and say self.cooldown equals, let's go with 10, self.cooldown max equals 10. And 10 will be our cooldown so we can fire 3 bullets per second. And I think that's all we need. Do we need something else? No, that should be good for now. Maybe we'll find it later when I actually start getting into this. So when we shoot, we're going to basically have to check something. If self.cooldown is less than or equal to 0, then we know our cooldown is good, so we can shoot. This way we don't shoot one time every single frame. That would be way too fast. So if our cooldown is good, then we can fire our bullet. What else do we need to check? Well, this will be a problem if we try and shoot a bullet and we don't have one. So we're going to say and, which means also. So if our cooldown is less than 0, okay, and we actually have a bullet, so we can say self.ammo, then that means we know self.ammo lists, if you just put them inside of a Boolean statement, like an if statement or a while statement, you can just say if list, then the list will return true if it has something in it, and it will return false if it doesn't. So you can say if list, which allows us to check if there's something in the list. And then of course we're checking our cooldown. So if this is the case, we want to actually spawn the bullet. So I'm going to say something called bullet is equal to self.ammo.pop. And pop is a list operator that allows us to take the last bullet in the list and return it to something. So we're taking the very last ammo, the one on the end of the list, and we're assigning it to bullet. So now we have an actual bullet or ammo object. We actually called them bullets up here, didn't we? Yes, we have a bullet object with us. So first thing I want to do is center it. So bullet.rect.x is going to equal self.rect.x plus self.rect.width minus bullet.rect.width over 2, I think. And this one's also over 2. Because this will self.rect.x plus width over 2 is the center of our player object, and then minus half the width of this, since the top left corner, or just the left corner in this case, the left side is the 0, we minus half of its width, and that gives us the center. And then of course the same thing for the y. We just say self.rect.y plus self.rect.height over 2 minus bullet.rect.height over 2. And this centers it inside the center of our player object when we shoot it. So when we shoot it, it starts off centered. And then when we actually have gotten done firing it, let's see what's next. We need to Since we're removing it from its ammo list, we need to assign it to a new list so we know how many active bullets we have. So I'm going to say bullets.append bullet. And before that, we're going to say bullet.getTarget, because this is where it's going to actually get its target, which is going to be our mouse position at the time. We don't have a list called bullets yet, so I'm going to add one under here. Bullets equals an empty list. That way we can cycle through them when we need to. There we go, bullets.append list. And I believe this is all we're doing for shooting. We're checking if our cooldown's good. We're assigning the bullet object. We're centering it. We're giving it a target. And then we're giving it a new list. And I want to say that's done. Yes, it is. So, no, it's not. We need one more thing. If we go inside here, then self.cooldown equals self.cooldown max. So, if we're able to shoot, we have to reset the cooldown. And while we're here, in the update, which is something we're going to call every single frame no matter what for the player object, we're just going to say self.cooldown minus equals 1. Because every single frame, we're just going to reduce the cooldown. This allows us to click and then wait and then click and always be able to have it ready as long as we didn't, click and hold it too soon or click too soon. It'll always be ready to fire the moment we click if we wait the cooldown at least. So while we're at it, let's add an update somewhere. Let's see, where are we going to run all of our updates? Do mass stuff. Let's run them all like right at the top, just so that we can guarantee the updates always happen. So that's still comment. I'm going to say updates, player.update. And now that's just going to take care of that. We're going to do other stuff inside the player update. The update is just something that's going to guarantee us something that happens every single frame. Much like how we draw it. Actually, we could draw it, couldn't we, inside of there, instead of having to say game window .blit player image in player rect. We could do the update inside of there, but we'd have to pass it the game window. Update it on the game window? Does that make sense? Maybe. We could also move the spawn delay and spawn ammo inside the update too, I guess. A lot of stuff that we could be doing. Maybe we'll do it later, but I want to focus on shooting this time. So we're getting the target. Well, currently the get the target doesn't do anything. So let's go up to our bullet and look at this. Now, get target is the most complicated one we have to work with, so I'm going to focus on travel right now. All travel is going to be self.rect.x plus equals self.xmove, self.rect.y plus equals self.ymove, because I'm going to change up xmove and ymove for the travel. And then, of course, the reason we needed to create the list is, I know I'm scrolling through this a lot, but let's come back down here. Updates, do math stuff. Player.move ammo, where we do this, we're also going to say bullets, which remember is the list that holds all of our traveling bullets, dot travel. Or I should be saying actually, for object in bullets, object.travel. And of course, this assumes we're only putting objects in the bullets. This is where the coder has to be smart, because if we don't only put, bullet objects, if something does not have travel that is inside of that object, we could have some very big problems. And we could do a check, but we know we're smart coders and we're not going to add anything bad. We're not going to add anything but a bullet object to our bullets list up here. So get target. This is the complicated one. Let's make a cursor, and we're going to set this equal to pygame.mouse.get position. I don't know if this is right. It's almost right. It's just get pose, P-O-S, not the full position. Now what cursor does is cursor is going to return us something that looks like this. Some x and then some y. It's a tuple of two values. So we can use that to our advantage by saying that, the x difference is going to be equal to the cursor, 0, which is the cursor's x position, minus self.rect.x. And then the y difference is going to be equal to the cursor at 1 minus self.rect.y. This gives us the pixel differences between our x position and our y position, which means when we actually do some traveling, we can say stuff like x move, is equal to the x difference divided by however many frames we want to move on. Say we want to move, by 10 frames. I'm just going to call this num frames, and then y move is also going to equal the y difference divided by num frames. And this is, of course, the number of frames that are, we're traveling across. So if we want to move at a constant speed, then we have to move a certain distance per frame. We can't just say, move your entire distance over 10 frames, because then the entire distance will sometimes be really close and sometimes be really far away. So I'll put it this way. Num frames, let's say this is 10, right? And let's run this. This should work. Actually, we're missing one thing that actually checks our click. So let's scroll back down to our game loop, our actual game zone, and check updates, do math stuff. Yeah, we can do it here. So what we're going to do, now we need to put a quick thing here. I'm just going to call it mouse equals pygame.mouse.get_pressed. And this is going to return us a 3-part tuple. This is going to be left mouse button, left, middle, and then right. That's what this is going to return for us. So we only need to check the left mouse right now. So pygame.mouse.getPressed, and then down here is where I was going to do it. We say if mouse at position 0, meaning if the left button is pushed, what are we going to do? Well, we're going to do player.shoot. And then, of course, shoot, when we call it, is going to come up to the player. It's going to say, if my cooldown is good and my ammo is good, I'm going to shoot. Otherwise, I'm not going to do anything. So I believe I wanted to test this. Let's see. Yep, now we can shoot. Few problems. It's not working yet. All we really need to be doing with these is the new objects aren't being drawn because we were drawing them from the player class. So we just need to redraw them. So we say game window.blit object.image at object.rect. And that should take care of the problem we have. I'm just trying to make this work so that we can see it. Okay, currently their X move and Y move are really bad, so... Why is it doing that? I thought we changed them at least a little bit. I'm probably just forgetting to do stuff. X move equals the X difference divided by number of frames. X difference is the cursor minus self.rect.x. Oh. Self.xmove, and this is where self becomes important, self.ymove, because self.xmove and something called just xmove are two different things. For example, self.xmove refers to the object. Xmove is a local variable only inside of the getTarget function. So I need to actually say self.xmove for this to work. Then we're going to run it, and there we go. You'll notice it's moving super fast because we're trying to move this thing from its start destination to its end destination in 10 frames. Do you notice something really awkward about this? Why do they move faster? See, when I put them right near the center, they hardly move. But when I click them out here, they shoot super fast. That's because it's moving its total distance in 10 frames. Its total distance is only a few pixels over here, and its total distance over here is really far away. So it's moving the full distance in 10 frames. This is not what we want. It doesn't look good. It doesn't really work well. It's not what we're looking for together. Now, the direction seemed pretty good. So the direction, there's not really a problem with that. However, the number of frames we travel on can't be constant. Because when we click at different distances, it is a different value. So what is the number of frames we're going to travel on? Well, that is going to be some type of magnitude divided by our speed. So self.speed. And we actually need to create this variable up here. So self.speed, we're going to set this equal to 10.0, and I'm making a double for a reason, or a floating point number for a reason, just so that we don't have weird, awkward integer dividing. So the magnitude is basically our hypotenuse. I believe that's what it's called. I haven't used math terms in forever. So basically, when you look at, one of these fancy triangles, this is our y direction here, this is our x direction, and then this is the thing that we're actually looking for. This is our magnitude, this, really long line. Because we take this line, divide it by whatever our movement speed is, and then we have how many frames it's going to take us to get there going at a certain speed. So our magnitude is going to be equal to math. We haven't imported math, have we? Nope. Let's import math. There we go. Now we can actually use math. So I'm starting to go fast because I know I'm going way over time. Math dot square root. What is our square root going to be? It's going to be the float. And I'm doing floats just again to avoid weird integer problems. It's going to be the float of x difference squared plus y difference squared. The double multiplier means squared, so y difference to the power of 2, x difference to the power of 2. I could just do 1 times and then x difference again. So what this is going to do, it's going to take our pixel differences of x and y, it's going to square them, and then add them together and take the square root. This is Pythagorean theorem, which is, a squared plus b squared equals c squared. That's what we're doing here to find the magnitude of the hypotenuse. And then we're taking the magnitude of the hypotenuse and dividing it by our speed. So the magnitude's always going to be different. If it's 100, then our speed is 10. It's going to take 10 frames to go that distance. If our magnitude is 200 and our speed is 10, it's going to take 20 frames to go that difference. Double the speed, double the time. That gives us the feeling of a constant speed. So if you see, now when we click, you'll notice we always have this nice constant travel time regardless of how far we're clicking. Now, it probably varies a little bit just because of integers and how they round, but it's never going to be, as severe as it was. It might be maybe a pixel more than we might expect, or some might travel a pixel more than others per frame, but that's not really going to matter. It's not like these ones when we click up here are going super slow and the ones when we click way out here are going super fast. So it's much more smooth. And of course, this one moves around. We can shoot in every direction we want. So there's not that much problem. Now for bullets, these are traveling wicked slow, so we probably want to fix that up. And we'll have to do that next time because this one has gone way over the time I wanted. We'll finalize our targeting to make it more like my example, because my example is a little bit better than this one. Just on some checks, making sure its accuracy basically is a little bit better, because I know I'm going way over time, but if I click here, you'll notice the Q is actually going a little bit above my cursor. So right there, the Z is not quite centered either. It particularly happens around this angle. If you'll notice, all of these letters are going above my cursor. They're not very accurate. We're going to fix that. So that's it for this one. Hope to see you guys next time.